I'm very happy to present you the very technical presentation and the start of the guys from Graz. And my first presentation is about the try to do a climbing style assessment with force sensor on a Boulder gym. Just a few words to myself. I'm a physicist, studied physics, then switched to mechanical engineering, and now I work more or less in the automotive sector. For my climbing career, started in the 80s, did my first AD in the 93, and tried some competition climbing. So what I want in my presentation, I want to think a little bit about the role of an engineer. Well, there's an athlete, but he needs a lot of other people, a coach, a team, a gym, his family, he needs money. And well, there is a new guy rising in the last few years, it's the engineer. And how does this guy fit into this setup? I will a little bit discuss. So what was my motivation to do this project? Well, the climbing style consists of a very low level of power, body coordination, and mental strength. To reach this topic means, and if you reach the top of a boulder, it just means you climb sufficiently well, but maybe not very good. And you can compensate weaknesses by force, by height, or just by simple luck. And what methods are there available on the market? Yeah, you can do some video analysis, you can do some feedback by a radar, but this is time consuming and expensive. And so my task was, if it's possible, to set up at least a prototype monitoring system to check if a boulder has been climbed in a good, predefined style, and the climber should get an immediate feedback during climbing, not some post-processing afterwards. And it should be operated in a climbing gym without any external supervision. And my focus was on the ambitious, but not the professional climbing, but sure the mass of climbers are here in the 6A level. And Schubert knows how to climb, so there's not much to teach. But I can teach him. So what was the hardware on the front side? Yes, there was a small display, just for information, but Then I decided to be very, very hardware on the hardware side, just two devices to select the type of boulder, the style of boulder has to be climbed, and the difficulty. And and there's just a small feedback, just an LED light for feedback. So as long as the lights are green, everything's okay. Red, the climber faint. I tried some acoustical information, but due to the background noise, it didn't work out. And sure, there are the forces, the holds on a three-dimensional force sensor. And and on the top board was just the one-dimensional force sensor. This was the setup I mounted onto the board. I just wanted to have any electronic device, any measurement device on the back side of the board, so in order not to get any damage to the system. And one very, very strong restriction was that I did not want to do any modifications on the board, because it's very clear, I can go to the climbing gym. I created the system. I don't know if you earn money, I don't know if it works, so then it will want to drill the hole inside. So this wouldn't work. So I just could use the existing screw holes for the mounting and the force introduction. And there's tons of electronics just to get all the signals processed and get them output. The operating was just to be quick. The signals of the holes are assembled by some devices, sent to a master. This master communicates to a laptop just to provide the data to a laptop if there's a laptop was available. Puts it to the analyzer. Then there comes the input from the climber, the challenge, and the level. Some kinds of electronics, and just the analyzer decides, the climber is on track, failed or the system is operated. So, what are the challenges what is the possible reason that the failure of a beginner or of a kind of a beginner in the intermediate level? Well, you can slip from a hold due to a force perpendicular to the wall. Too much force on hands, not feet. Feet are not used for pulling, this is a little trick. Or there are disruptive movements. And so the challenges I implemented was speed, climb as fast as possible. Close, this was to minimize the ratio of the force perpendicular to the wall to the total force. This was not. Then no hands to minimize the forces on the hands. Feet to pull the holds with the feet. And smooth glide as smoothly as possible, as some small vibration are always an indication that the climber is at the top. So I just skip over to, as I sent my data to the laptop, yes, I have tons and tons of data. But this system, I didn't focus on data post-processing. I just wanted to have a system which just gives two indication, failure or not, and immediately. I did some evaluation. But there's how much time is left?
3.5.
Okay, so that, if somebody wants to know more details on the time around the data processing, we can put that on. So, but what are my lessons learned? The mounting of the system is possible without changes to the wall. The mounting is very, very tedious. If you just have this tiny screw holes to connect. And it took me. I think this is the problem of all guys who try to measure forces. On the whole, there's always you have to have a distance between the wall and the hole, just that the wall doesn't the forces. And if you don't mount it very, very carefully, you just have this slip. This is quite difficult to achieve because you install the system behind and just have a look in front if it's right, and it's very, very tricky. In my opinion, the improvements are necessary and possible. And what is my experience? Well, the first prototype operated for 2 months, 3 months on the climbing gym. Did a lot of improvements. I got a very good insight into the climbing style. So there were a lot of guys who didn't even arrive to hold the first hold. And there are especially competition climbers who are really very, very good. I personally saw that my climbing style is quite good after some 30 years of climbing, but I might like the force cut. I know this is not true. The climbing, I've seen a lot of guys who really hit the boulders much better than I expected. And this challenge close, where you have to reduce the force perpendicular to the wall, is the most interesting one. And that's what we have discussed is the costs. It's just three-dimensional force measurement is expensive, and I just can't imagine that. Maybe there is some way, but I prefer to. I prefer to use commercial sensors. So this is really an issue because now I estimate the three-dimensional forces alone cost 800,000 euros. So if you end up with 1,200 euros a hold. And what I already experienced is integration into the operating procedure of a climbing gym is very difficult. The climbing gym operator has tons of problems, and some technically more or less it's not his major concern. So now the acknowledgement, and I'm open for questions.
Thank you. Are there any questions?
contact work could almost be integrated into the climbing wall. So, when a route setter turns up, there's certain bolt holes that they know that already is a force sensor connected behind them, and they can build their problems accordingly.
Yeah, I think it's possible, but you have to allow a small modification. Just I already know that there are guys from Turin who already built such a system, but you have to allow some modifications, especially just a hole with a diameter of 3 centimeter instead of this 1 centimeter screw hole. But it's not that easy. Yeah, it's possible, but not easy.
A question, Justin?
Have you thought about going the other way around? There's some nice sensors where the sensors on each finger of the glove for industry in terms of like picking up things. So you can measure force just in all hands and all fingers, and it's in real time. And the software integrates all forces at once.
I did such a project, but not with humans, but with horses. So I integrated this kind of sensors into a horseshoe, and we tried to do some measurements, but it didn't work out. I think gloves, climbing with gloves is difficult, and it's not comparable. As well as our horse, we went on strike as soon as we put on the measurement device. And we had a lot of problems. Maybe already some years ago, maybe the sensors increased, the quality of the sensor increased, but just 5 years ago I did this master thesis. It didn't work out that there was a steady drift of the sensors, so we cannot.
I've only seen some commercial ones that are very, very thin, almost no contact to the skin. And,
I can't imagine.
They look like